All right, that's not it, is it? All right, so the next part, it's impossible for the angle theta to become 90 degrees and both ropes to be horizontal. Use your 3 case diagrams above and explain why. So the 3 cases, we're dealing with a hanging sign here, where we have a horizontal force and then an angled force. So again, if both forces are exactly horizontal, then that means we'll have this one, FTH, and then over here. Well, what is canceling out this downward weight force? It wouldn't be anything. So that would mean the sign would fall. That's a sufficient enough explanation. You can put that in whatever words you want. And then explain using your equations. So for FB, the first force that we completely found, it is mg over cosine theta. Again, if you take your calculator and you type in cosine 90, I don't know what you can see, you get that. 0. We've got 0 in the denominator. Math teacher will not be pleased with that. And for the tangent, if we type in 90, for the second force over here, remember sine over cosine is tangent. So for the tangent function, when we plug that in, oh, it's just a mess. An error. Domain error. No good. So those are your explanations. For the next piece here, in the diagram below, a sphere held by rest is by a long cord and a short cord. Which cord has a greater tension? Use a free body diagram where the ball's weight is 5 squares to justify your answers. Gladly, because I love a good free body diagram. 1, 2, 3, 4, 5. Why do I love them? They're easy. They're free. 3 points. M and G. So there's the weight. So if I were to look at the tension forces, we've got this one goes 1, 2, 3, 4 up. So that's what we're going to do over here. And it's going to go up 1, 2, 3, 4. And it looks like it goes to the right 1, 2. We're going to call this rope A and rope B, just so we can differentiate between the two tensions, because we'll have two FTs. So we have FTA right there. FTB looks like it just goes up 1 and to the left, however many we go to the right. So it goes up 1 and to the left 1, 2, 1, 2, up 1. Now you may be asking, how did you know to draw it like that? Well, remember, it goes up by 4 for this first rope because it's closer to exactly being vertical. And if it were exactly vertical, then the rope would just equal the weight, as long as it's not stretching or falling or shrinking or anything. So that's where most of the weight is going to come from. It's going to come from the closer to the full vertical tension. So we have 4 going up for FTA, and then we only have 1 going up for FTB. So that means it's completely balanced in the vertical. I think that does it.